So let's have a look, guys. So what we're doing with our folio task is it's divided into two parts. Okay. We'll have a read of the text here, and then we'll talk about specifically what part you're required to do. So, just firstly, what is a folio task? It's an assessment task that you take home to do. It's going to be 8 pages long. You're going to write it up on Microsoft Word. So it's a maths task that's like an assignment that you take home. A bit like an essay that you write, but there's more maths involved in it. Okay, so we'll have a read here. A roller coaster is a type of amusement ride that employs a form of elevated rail track design with tight turns, steep slopes, and sometimes inversions. People ride along the track in open cars, and the rides are often found in amusement parks and theme parks around the world. Okay, your task is to design a roller coaster using a variety of functions. With appropriate translations and dilations. The roller coaster is to have a horizontal length of 400 meters and is to be made up of a variety of functions. You'll be able to use technology to assist you, but it's good to show calculations in order to demonstrate understanding. So that's the general task, okay? Now there's going to be two parts to it. We have, firstly, what we would call a basic roller coaster that you're going to solve these problems for and then graph it. We'll get you started on this today. All right, so we can see, find the equation of a line, find the equation of a quadratic, find the equation of a cubic. Okay, we've done those kinds of equations before. And then we're going to sketch them on Desmos. So we will get started on that today. Following that, what you'll do is create your own. Okay, so 400 meters long, maximum height of 50 meters, and we're going to be using all kinds of equations. Lines, quadratics, cubics, quartics, circles, and we learned about circles. We didn't learn about ellipses, but we can have a touch on those. And then for a further extension, we can experiment with a variety of functions. Okay, got a couple of useful links in there, some discussion questions. All right, so let's start then at the start here. And what we'll do is we're going to solve, we'll solve A, B, C, and D together, I think. And then we'll leave E, F, and G for you guys to solve. So we'll solve A, B, C, D together. And then we're going to graph them on Desmos. So we're familiarising ourselves with what we need to do here and how to sketch it on Desmos. Okay, so we're going to solve through question A here together first. It says, find the equation of a line which passes through 0, 0 and 2346. This represents the initial incline, so it's going up where the roller coaster generates potential energy, gets really high, and then we convert that potential energy to kinetic energy as it moves down the roller coaster, right? So we have question, I think my camera lens is sort of there kind of thing. So let's get rid of that from there. And that. So equation of a line passes through 0, 0, and x is 23, y is 46. So this is taking us back to the previous unit. And now my recommendation is that we do write this down. It's going to help you. You've sort of got somewhere where you're starting the assignment for you to type up a bit later. So the equation of a line is y equals mx plus c. Right, that's the equation of a line. Now, the first thing we need when we're finding the equation of a line is the slope. So the slope of a line is y2 take y1 on x2 take x1. Now, in this circumstance, what we've done in the past is we've gone through and gone, oh, yep, x1, y1, x2, y2. Remember, it doesn't matter which one we assign subscript 1 or subscript 2 to. And then we'll just substitute them into the formula. So at the top we have y2 take y1, that's going to be 46 take 0, divided by 23 take 0. We'll simplify this, it's 46 divided by 23, which is 2. The slope is 2. So that means for the equation of a line, we would have y equals 2x plus c, where c is the y-intercept of the line. Now, in order to determine the value of c, we would then substitute in either of these coordinates. All right? Now you might be already able to see the value of c, but I'll just take you through the process. So let's substitute in this one, because that's going to be nice and easy. We have when x is 0, the y value is 0. So we'll put 0 where the y is, and 0 where the x is. All right. 0 is equal to 0 plus c. Well, c has to equal 0. All right. And of course this is true. Of course this is true based off of this coordinate here. When x is 0, that's when the y-intercept occurs. When x is 0, the y-intercept is going to be 0. And so this is the equation of a line in direct proportion. All right, so remember, here's our Cartesian plane. It's starting here. It's going straight through 0, 0, straight up. Very good. Okay, so that's A. Now what I'll do is I'll make a list of the equations we've got. We've got y equals 2x for A. All right, let's move on to the next one, which says, find the equation of a quadratic with a local max at 2851, which goes through the point 2346. Okay, so it has a local maximum. Now what that means for the quadratic, okay, here's our Cartesian plane, has a local maximum, all right? That means we're given the coordinates of the vertex, and the vertex is x is 28, y is 51. So what we should be thinking then is the equation of a quadratic in completed square form is a times x take h squared plus k. Okay, that's from our previous unit. You can see we're drawing on all of these skills that we've learned. And we've got the coordinates of the vertex. We've got x is 28 and k is 51. Okay, so that's the form it takes. And we're also told that it passes through x is 23, y is 46. So we'll have when x is 23, y is 46. So we're going to substitute that in order to determine our value of a. So we substitute in 46 for y and 23 for x. Let's process this. 23 take 28 will be minus 5. Now, first thing I'm going to do is take away 51 from both sides. Okay, so I have 46 take 51, that's going to be minus 5. Now, minus 5 squared will be positive 25. And then we'll divide both sides by positive 25 to get a by itself. And that will simplify to negative 1 on top of 5. Okay, so that means we've got our equation for B. We've found this A value. Negative 1 on top of 5. X take 28 squared plus 51. Okay, so processes that we've done may be a little bit of a stretch, but we'll go through the first few with you together. So that's B. Let's have a look at C. Find the equation of a cubic in the form minus x take h to the power of 3 plus k with a horizontal translation of 28 and a vertical translation of 51. Now all this means, this one's not too bad. So we have a cubic that has this form, minus x take h to the power of 3 plus k. All right, and we're told horizontal of 28, vertical equals 51. Now, all that means for us is h equals 28, k equals 51. So the equation is going to become negative x take 28 to the power of 3 plus 51. Alright, so we've got equation C there. And we're after one more equation for D. D, find the equation of a quartic which touches the x-axis at 34 and 40 and passes through the point. X is 37, Y is 1.62. So you can see the numbers are getting a little bit, they're not so clean as they used to be, are they? So if we have a quartic that touches the x-axis, if it's touching, we know that those are squared factors, right? So it's touching at 34 and 40. So what that means is our quartic is going to take the form x take 34 squared. Whenever it touches, it's a squared factor, multiplied by x take 40 squared. That's the form that it takes based on where it's touching. Okay, and we have it passes through 37, 1.62. That means when x equals 37, y equals 1.62. So we'll substitute that in. And process. Sorry, that's positive 3. That's negative 3. And so we'll have 1.62 on 81. That's going to equal our A value just from processing it through there. And so we have our equation for D. Okay, so what we'll do next is I will get you guys, if you've finished that, to do pull your laptops out. We're going to go to this website. We've only done the first 4, right? So I'm going to leave the other 3 for you guys to have a wrestle with. There's a circle, a line, a circle and 2 lines. So I think we should be okay with that. So we can pull our laptops out. And we're going to go to this website called Desmos. All right, if you just type in DESMOS into Google. And just on the equations that we developed 4 equations, and we'll just make sure we use the notation that the assignment gave us. So they said the first equation for part A, they said was f of x. So we'll make sure we use this notation. F of x is 2x, and then we have g of x, and then we had, was a h of x, and then m of x. Okay, so they're the equations that we found. All right. So what we're going to do in Desmos, okay, so we navigate to Desmos, you press Start Graphing, okay, or Open Graphing Calculator. Okay, it pops up to a screen like this, everyone there? So the first thing we're going to type in is our first equation. We click up the top here, and we're just going to type in f of x equals 2x.
How do you do negative 1/4?
For the next question, so everyone done f of x? We're on to g of x. What we're going to type in is negative 1/5. Negative 1/5. And then we're going to type in x take 28. We close the bracket. And then we press Shift 6 because 6 is the button that has the little hat on it. All right, Shift 6, that takes us to the power of 2. And then we have a plus 51. Now, we've graphed it and we can't see it. All right, that means we're going to need to change our V window. So, we've graphed 2 functions so far, but what we'll make sure we do is we're familiar with this tool over here. See the spanner up in the top right corner? Graph settings. Okay, we're going to change some of these around. So, for example, our X minimum is going to be 0. Wait, don't do that. Our X minimum 0. And we don't know our X max value yet, but we do know we were putting in X values of 40. All right, so let's go for an X max of 50 for now. All right, and we can see there's the blue equation. And we also know for Y values, we had a Y value of 51. So let's put in a Y value of 60. Sorry, that's my label. For my Y max, I'm going to change that to 60. Gorgeous. Okay, so we can see those 2 equations there. Now, before we get to the third one, we're going to start to restrict the domain of these functions. So you can see not only are we bringing the functions, but we're also bringing in our knowledge of domain, which is really good. So for our first function, right, we're going to have the incline from 0 up until we get to the blue function. We can, if we click near it, it will tell us where they intersect. Okay? Now what that means is for the first function, we want to graph it from 0 until they intersect. So we're going to go, what we press is we press Shift and we've got those curly brackets. All right, so depending on where your keyboard is, they're the same button for me as the square brackets as well. And I'm just going to type in between 0 and 23 for X. Close the curly bracket. All right, so you see, I've got the open curly bracket. I type in, I want X to exist between 0 and 23. 0 less than X less than 23. And they're the points over which I have graphed it. Okay, well, I'm going to float around and see if anyone has any questions about that. So minimise your super coach if you've got that open. Yep, good. Excellent, well done. Okay, which means for our next function, for our blue function, it doesn't start until X is 23. So the first thing we're going to do is we're going to put a bracket here. And we'll put 23 is less than X. Whoop, not capital X, lowercase x. 23 is less than X, but we don't know what its upper value is yet. Okay, we're going to just leave it for now and we'll put the next function in. So we've got f of x, we've got g of x. Now we're on to h of x. So we're looking up at the problems that we solve. We have h of x is equal to negative x take 28 to the power of 3 plus 51. All right, so what's happening is you're going up, you have a curve, and then you have a really wicked decline. Like, look at that slope, straight down. So, what we'll do is we will G-solve the first point of intersection. All right, so the first point of intersection is 2851. Now what that means is we're going to restrict the blue function. The blue function is going from 23. We're going to stop it at 28 because that's where the green function takes over. So I'm going back up to my blue function and I'm going to restrict that to 28. All right, 23 to 28. And it means the green function is going from 28 onwards. We don't know where the green function is going to stop, but we're going to restrict the green function for now. Okay, so we've got 3 functions there coming together to form a roller coaster track, 2-dimensional roller coaster track. All right, any issues? Okay, so we're on to our last one then. We have we have m of x. Good. Get rid of those capitals. M of x equals, and we have 1.62 on top of 81. And we've got x take 34 squared times x take 40 squared. Okay, this time, now it's up to you where you call the point of intersection. I'm going to, because you're not given the definition of the domains, so I'm going to call it there at x is 31.47, we'll round it to. So what that means is the green function exists until 34.17. No, that's not right. 31.47, sorry. Wait. So I'm restricting the green function to 31.47, which means the blue function will be from 31.47 onwards. Okay, so you can see we're starting to develop this roller coaster here. We have this incline, goes up, goes down, we've got these cool things, and then the next function's going into a circle, so we're going to have a loop-de-loop, and then we have a couple of lines and so forth to finish off. Alright, so that's how you're starting the assignment, alright? Now I'll just point out about Desmos. You can save the graphs. I don't remember if you have to make an account or not, but it's a good idea to save it or to make an account, because when you are building your own roller coaster, you're going to want to keep coming back to it and adding to it. Okay? So for now, let's focus on part one, and in a later lesson, or else I can show you some other video footage, we can have a bit of a look at part two. So I think I'll stop there. Are there any big questions people would like to ask? All right.
In the folio, do we have to do our working out?
Yes. Yep. So you can't just have answers. I want to see working out. So what I will show you